In early 2016, a security bug was reported to Uber that could allow remote code execution on rider.uber.com. A severe security bug, which we could say it gets 9 or 10 out of 10 CVSS rating. This is a screenshot of the bug report that was given to the Uber. And it was relatively simple to create. As a matter of fact, a user could go to rider.uber.com, change their profile name to this input or payload that you can see here, and wait for Uber to send the user an email. And what you will expect to receive in an email is the following. If you look closely, you can see there is something slightly wrong with this email, the content of this email. The placeholder for your first name or the profile name is filled with 7 times 7. Obviously, the bug was severe, and Uber eventually rewarded the security researcher with $10,000 at the time. And this example of the situation where what was given in the profile field was executed on a backend server is known as remote code execution. That is to do with, which we will see today, that is to do with unsafe usage of a template engine. So to understand what actually went wrong, we need to first cover a bit of background around what a template engine is. It is a library that is used to build commonly user interfaces. It is also can be used to build configuration file and different documents. Now, the interesting part of template engine is it comes with an expression language, which is evaluated and rendered at runtime, given the values, given the context where the template engine runs. So think of an expression language as a mini language that is inside a template engine or a template that you write. And this gets evaluated at runtime. And that's a key thing about the whole problem of this bug. Expression languages are powerful in a sense that they can be used to access different code. They can be used to access different objects, attributes, different classes, or whatever is live in an environment where the program is loaded. To give you some examples, let's say we are using Java and we are using a Spring. A Spring has an expression language called a SPEL or a Spring Expression Language, which is defined using the following syntax. Within this syntax, we can even access things like different classes and properties of those classes. Or an example of JavaScript or TypeScript, a popular template engine or library is called POG. And it has the following syntax, and the expression will be defined within that syntax. And Jinja2, which is a popular expression language, a number of template engines are inspired from Jinja2. And Jinja2 is not just limited in Python. There is a port of Jinja2 available in languages like even C++ these days. And it starts with 2 curly brackets, following with the expression and closing the curly brackets. So if I want to go through one example, let's say in our code we are using Jinja2 as a template engine, and we have a template defined such as following and a string hello, and say we are using this template to build a HTML page on a backend. And we have, we will define a placeholder for a dynamic value that will be replace with at runtime with this placeholder. So let's say a request comes into our program, and we will gonna use this template to return a page to the user, and this request contains a query parameter called profile with a value Alice, all user controllable, or in another sense untrusted. And behind the scene, this value will be received by that template engine, and then we will pass on to that the placeholder of this variable profile, and then we will gonna get that value coming back. Now, most likely, you may think by now, hey, I've got something that I control on the page, meaning that there is an input to a thing called profile, or a query parameter profile, that will echo back on the page. Well, the first thing most likely comes to your mind, or if you have been doing security assessment for a while, like, what about I start entering things like that? A JavaScript tag or any other HTML tags, and well, let's see if that will result into cross-site scripting or XSS. Because if that's the case, because I would then be able to replace this proof of concept alert one with maybe another JavaScript code, and it is a GET request, so it's in format of the URL. I can pass URL to other users. Once they click, my desired JavaScript code will be executed on the page. Unfortunately, or fortunately, that is not as easy that we may think. The majority of these template engines, they have escaping mechanism, or they perform context-aware output sanitization, which means that they are very well aware that which part of the template this output will be rendered, and given the context of that, they will perform some escaping of the special characters. In our case, it was a HTML escaping of those special characters was performed, and well, the attack failed. Good thing to have. However, let's just not be super happy. How about instead of a JavaScript tag, you are entering an expression as part of the input to that variable? Well, that is where the problem starts to happen, even more severe than the cross-site scripting situation. The expression language that was the expression that was specified by, well, through an untrusted field is now got executed and the result is returned back to the user, which is quite bad. We are not even limited to that. Now we have the whole expression language available to us to explore and find out different ways that we can access different parts of the code, even execute code, write to a file, read from a file. This is just one example again here, that suppose within the profile object there is a property called secret that's supposed not to be displayed to the outside world. Well, now that you can provide an expression as an input to that untrusted value, well, you can go and access that object, that secret object. These are just toy examples before we dig into the lab for this workshop. So the danger we are facing here is that obviously our program is now open to remote code execution, meaning that in the context of that expression, someone is able to enter something, and that expression gets evaluated and the result will be returned back. In very, very minimal cases, it could result into information disclosure. So if we have some environment variable, if we have some properties that we are not wishing to expose them to the outside world, well, that expression language gives that ability to to an adversary to be able to access them. This bug or security vulnerability is known as server-side template injection, and server-side being that it's applicable on a server-side template engine libraries. Just on a hint side, there is also client-side template injection type bugs, which we will not gonna go over them in this workshop. And this server-side template injection, or SSTI, which I will be referring from now on, it happens when untrusted data is used in a server-side template engine in an unsafe way, and it results into code execution. We can nominate two root causes for this vulnerability that can emerge, which I commonly see in code bases. One is that the untrusted input, in our example, that profile query parameter, is used to build the parts of the template or parts of that expression language. For example, cases where we are using plus sign to concatenate multiple strings together that will eventually build that template for us. We will see an example of this in the lab. A more common and hard to find root cause of SSTI is double rendering or double evaluation. This is where a template gets rendered and processed twice. This case, as I mentioned, is quite common, especially in the microservices architecture, that we may have multiple services involved in processing a request, and we may passing different templates across these services, and we may end up having a double rendering issues, which I guess that was also the cause in the Uber incident. All right. I want to now move into the lab. And in the labs, we are going to see an example of intentionally vulnerable program to SSTI across multiple languages. And we're also going to see how we can identify this bug, how we write a security test for them, and if we have time toward the end, we're going to have fun of doing some exploitation to just really sense that how bad an SSTI can get into. So to access to the labs, you can head into learn.secteam.com, and right here you just need to sign in. I've already signed in here. Let me log out and log back again. So learn.secteam.com again, and hit on signing button here. Log in. And for our first lab, I have picked TypeScript. Scroll down. These are all the courses available for you. You can pick any of them to play around. The one that we are going to cover today is called Uber Rider RCE within TypeScript. Click on here and head to the lab for this course. All these courses are designed to be completed in 1 hour. So we're just heading to the lab part. And right here, you just need to hit on the download button. And this will give you the Git URL for the code for this lab. And what you can see also here is the guide, which takes you through the steps that you need to do to perform this lab. All right. Let me move to my terminal here. And I have already cloned this repository. Let me just give you an overview of the labs. If this is the first time you are watching our monthly workshop, each lab contains a Docker file and a make file, and also a source directory which contains that intentionally vulnerable program, following with a README file, which is a guide that you already see on our Learn platform. A Docker, we have containerized every lab, so you can simply run it. It installs all the dependencies and brings up that program for you. To run the lab, you need the latest version of Docker, and also you need make, which is available in the majority of the Linux distros and OS X. To run the lab, you simply type in make build. This will go and fetch the original Docker image, and then it head into installing the dependencies. This will take a while to run, depending on the images that is available, Docker images that is available already in your system. But just give it a bit of time. So hopefully this will finish soon. Right. Meanwhile, as this is being built, I will move into the lab structure, just to take you through a little bit about how the code is structured here. So I'm opening the TypeScript lab, and within there we have a source directory which contains the program, and in this specific example we are using a framework to build the program, which is called Ssdi, and which has a controller, which has a test and views. You will get familiar with all of these. Now if you open up the controller, well, there's an index file which had some bootstrap code to bring up the lab, and some controller which defines different functionality of this. Let's leave this now. I think that the lab is already built. So we go back to the terminal. So anytime you see this message, that means that everything is done, dependencies are set up. Now you can continue running this program. Just simply type in make run. This is going to run that Docker image for you, and in this case it's a web application, and now we have a port 8080 open that we can access it to view that web application. All right, let me move back to my browser, open a new tab, head to localhost port 8080. Now here we go. A simple application which receives two inputs, well, first being the first name, the other one being the last name, following with an update button. Let's hit that. And as we can see, dear Alice, your profile has been updated, Ubur, happy team, and we can see that was a post request sent to this endpoint called update. All right. Now let's move back to the Visual Studio code, and we have a look at this code a little bit together. So to find out what actually happens, there is a number of other files just to make this TypeScript lab to the application to run. I will skip them for the sake of time now. So just head there, go to the controller, and open this file called update.ts, which has the main logic of this program. Within there, we can see there is an endpoint defined as update, which will receive our post request. It will parse the post parameter and pass that into a variable called payload. The first thing it does is it will run over this validate ID function, which will take in the ID, which if you scroll down here, it doesn't do anything special. It's effectively check if ID equals to 20. All these labs are intentionally kept very simple, so we just highlight the vulnerability itself. And then later on, it calls this function called update profile and pass in the first name, last name, and ID. And again here, nothing special happened. In reality, you may here have a database, a round trip of updating this user's profile, name and first name in a database. And once all is done, on line 10, what we can see here is a mailer function that will get only the first name. Perhaps this gives you some hint that this lab is resembling the the incident that happened to Uber. So let's look at the mailer function, what's happening here. Similar to many other mail functionalities, you may have a template that you use to create an email content before you sending it to the user. So here we have our email template defined right on this line. For simplicity, we just use a bunch of string variable to show the template, but typically this could be inside a file. And we are using TypeScript, and the template engine that I'm using here is called Pog. All right, so I'm not really going at this stage to the specific. The only thing we need to remember in Pog to have a placeholder for an attribute or for a variable, we use this syntax, hash, open curly bracket, following with the name of the attribute, following with the close bracket. And what happens here is that right here, when there is a render function is called, we are getting that template and passing that first name variable, which comes from all the way up from the body parameters. And once that is done, anyway, in this lab, we don't have example of SMTP server to send out this email. We just console log that out, so print it out on a terminal and returning that template back to the caller. And here we use the result of this template in this return statement where we just show a confirmation page to the user that, hey, that profile has been updated. All right. So now what we learned from this code is there is a mailer function that will use an untrusted value to build an email template. And we also find out that this program uses a Pog as a template engine. Let's move to the browser and look for Pog a little bit in more detail than what it is, to learn a little bit more about this syntax. So if you just scroll down right in the middle of the page, you can see an example template for Pog, which is similar to that email template we saw earlier, which, for example, to start an expression, the placeholder or the syntax is you start everything with a hash and a curly bracket, following with expression that you are interested and closing the curly bracket. This is an example of many other features that this, as you can see over here, that this expression language can give to you. All right, with that in mind, let's head back here and try to be a bit more curious. What if, instead of Alice, I try to, well, let's try that cross-site scripting payload right here. Maybe script, alert, and a script. Update. Well, as you could expect, it didn't work, because if you look at the source page, you can see it is being escaped. All right. Now, what about if we head back here, and instead of this script tag, I enter a Pog-friendly expression. And maybe for this expression, we try something like an arithmetic, like 7 star 7, similar to the incident that was discussed, and hit an update. Well, if you look closely, there is something interesting right in front of the first name, which is 49. All right, so what went wrong? Let's head back to the code. So as we could see, the first name was a parameter come from the user or untrusted source, and that was used to populate this part of the email template. So when I passed in effectively that expression, the Pog renderer at this line, it went and replaced this with this expression that I had, because it considered that as a value for first name. In the original case, when you enter Alice, it replaced that first name to Alice. But in this case, it replaced that with this expression. Now, there is nothing wrong here. So this is effectively after line 20, this will be the content. This would be effectively the content of T. So effectively T now is this. Now if we go back to the caller, we can see the result of this mailer, which contains this new template now will be sent to another renderer function. And this is where, as you could imagine, the double rendering is happening. That template is now contain an untrusted expression that is being evaluated again, and this will be written back in the page. So that's now makes sense why we saw Alice 49. All right. Now, before I continue and we dig into writing a security test, let's explore the same problem in a different language. Let's again head back to Learn platform, and this time I want to pick Python. And again, you head down to Uber right here, hit on server-side template injection, press on a download button to receive the Git repository, Git clone it locally. Let me move back to my terminal now. Let's stop this currently running lab. And try to run this to Python this time. And type make build, again, to build this lab again. Okay, it shouldn't take long for this to finish. Right now it's gonna install some Python dependencies. The Python lab is following exactly the same scenario of the TypeScript lab. It just implemented using a different framework and a different template engine. As part of the build process, it also runs the unit test, or in this case, usability test, just to make sure the program should run as expected. All right, so once you see this message, we can just hit make run. This will bring up our web application based on Flask. Now let's head to the browser again and go to localhost, hit refresh, and yep, exactly the same look and feel. Try to play around with some values, slightly different output, but again we can see what we saw, what we enter as a first name now being echoed back. Well, let's go ahead and enter our JavaScript payload. Try that. Well, you could imagine it is being nicely sanitized. Okay, let's now move to look at the code. All right, let's go here, and I move to Python here. So what we are having is a source directory. Within source directory, I got the main program here. I need to get rid of the changes I did here, so we can use that again later. Following with the two test files, which I will cover them later. Our main program, well, main.py, again, intentionally very simple. We have two endpoints. One is for root, the other one for update, which looks at the post requests here. And the first thing it does, it will run validate ID over the ID form parameter. And if we scroll down, the ID only checks if the value of that given value is 20. If so, it returns true, otherwise false. And then it follows on to call the update profile with the values first name, last name, and ID. Same thing, not implemented. It doesn't matter. And our mailer function, which will receive the first name, which comes from that form request. And if you look at the mailer function, we can see a different email template syntax. This time we see double curly bracket, which gives us the idea that it's a different template engine. If you head back on the top, you can see, yep, it's used Flask, and Flask by default uses Jinja 2 template engine. Render template and render template strings, which they will effectively run a Jinja 2 parser on behind the scene. And for this template, we are passing a context, or let's say variables, and in this case, the first name being passed in, and right here, we are rendering the template, given that context. Again, we don't have SMTP service, so we're just printing it out, not a big deal, and we'll return back that T parameter to the caller. Now, there is something slightly different here, but we will see later that it actually doesn't really matter to identification exploitation of this bug, that return template is being concatenated to this debug output. But on line 40, we will see again a double rendering happening. This is a return page that we saw on the browser, which contains this template and the T that is a template rendered by the mailer function. Now, one caveat some of you may have thinking, you may not necessarily have mailer within the same code or same function. This could be a different service that will pass in, well, the response to our original color. Again, for simplicity, we have put everything inside one event file. In enterprise type programs, you actually have a separate service which runs your mailer, but mailer may return by the content of the email body that was sent to the user, perhaps for login purposes, or perhaps passing them on to the original caller for the purpose of confirmation with the user. Perfect. So what we have learned is a double rendering situation, and we are using Jinja 2. All right, let's play around. Let's go back to our browser. And this time I'm going to search for Jinja 2 template syntax. And perfect. If you head down to template designer documentation, synopsis, it gives us a quick overview of the things possible, the syntax of different things within that expression language, statement, expressions. If we, for example, if you to look at the way how we can define a variable here, you can see double curly bracket following with the name of the variable. You can even access the property of that, obviously class, either using dot method or calling it this way. All these things will later on we will be using, so that's why I'm a little bit pausing in some of those. Okay, let's now go back to the program, and this time let's try double curly bracket following with the expression that we have. Why not? Update, and there we go. Remote code execution. Well, most likely calculator at this stage more than anything else. All right, one more thing I want to show here. As we know, it's a variable, so effectively if I know a variable name at the moment, theoretically if I put that variable name inside these two curly brackets, I should be able to get it out. Now I know in Flask we have a variable name called config. It's global, so it's accessible across all code base. And as you can see now, in this case, we can get a dump of that variable being returned back. Why it's matter? Well, this variable could contain some sensitive information, such as, for example, a secret key that we can see here, and quite a lot of things which we will see them later. Okay. So far you may be thinking that, well, I made an example of two scripting languages. This problem could be only limited to scripting languages because behind the scene, well, all these scripting languages, they are being evaluated and executed at runtime. What about more like type-safe languages? Do we have the problem there? Well, the sad part is yes, this problem, it also happened on a type-safe languages. Now for that, we go and do an example of this SSTI in Go. And if you scroll down all the way down to the Uber example, like before, head to server-side template injection, hit on download to receive the URL for this lab. Okay, now let me move back to my terminal here. Kill this previous lab, and now let me head to Go and server-side template injection. Make build. Again, just quickly, we have Docker file, we have make file, and we have a source directory which contains our Go program. Make build. As part of the build process, you can see here we also run our usability test just to make sure the program runs as expected. Okay, now the program is built, compiled, ready to use. Make run. Head back to the browser and let's have a look at this program. Localhost port 8080, refresh, Alice, and some random family name, enter. I can see the things are popping out. Now one thing I just want to make sure that clarify, not all the template engines are saved against the example of cross-site scripting. You need to, like, this is one example that you can see here, like by default, the way that this code was implemented, the output of the example for cross-site scripting payload was not get sanitized. Well, anyway, this is not our target here. So we can see what we enter here, we'll code back. Let's now learn more about the code. Let's head back to the code. And this time I open the Go code. So inside the source directory, we have a file called app.go. And in our Go code, we didn't even use any framework. Go is powerful enough to give us all the functionalities we need to render process a HTTP request. So we're just using the stock standard template engine that comes with Go and following with the HTTP parser that it has. Within our main function, we define two handlers, one for root, the other one for update, which calls this update function when there is a request comes in. Now, if we look at the update function, we can see a similar logic. We are looking for, a value, a parameter from a form called ID, and we pass that on to validate ID, which simply checks if this equals to 20. Following that, we create a new instance of this struct that contains our ID, first name and the last name. Following with the update profile function, passing on. So to this struct, I should also mention, we are passing those values that come from the form, those untrusted values, ID, first name and last name. We're passing to the update and doing nothing here, doesn't matter. And then eventually our glorious mailer function, which will pass in that struct to there. And within here, I'm first defining my template. Imagine this is like email template. Within there, I have some placeholder for the things that I will be replacing. And this execute template behind the scene will compile and render this template. So two things within the same function. And I'm passing in the first name from this object, from this struct. So it will be replaced at this part of the template. We don't have SMTP server. We are just printing out the email content, so the email body content, and we will returning back that template that we have generated. Again, the result of that is used to build that page that was sent to the user. So, big elephant in the room, another double evaluation issue right here. Okay, so what we learned, a double evaluation issue, and by default we are using HTML template. So let's see how we can identify this bug at runtime in Go. Head back to the browser, and here I want to search for Go HTML template. The standard Go library, Go package, different languages, different terminologies. So we can learn here that package template, it uses as a data-driven template for generating HTML output saved against code injection, and it is based on text template. So effectively, if you want to learn more about the syntax of this template engine, we need to search for the other one, which is based on text template. Heading there, well, this looks more familiar. So yeah, so this is where we can see that, for example, for a variable, we have double curly brackets similar to the Jinja 2, following with a dot and name of a variable, and yeah, things like that. We can even do things like some comparison using this syntax, and if condition statements, and there are quite a lot of things and a number of functionalities. Perfect. Let's head back here, hit refresh. Alice Smith, and this time, well, we know that if we use dot, something happened. Maybe I pick one of those variables that is there. Let's see if this will work. So first name, I haven't tried this before, first time. Well, dear Alice, didn't work as I expect. How about I just use dot instead? This hopefully will dump the whole object out. Yeah. So as you can see here, I got that user struct out ID, the first name, which now contains that curly bracket dot, following with the last name. So being a type-safe language doesn't necessarily save us from this issue, which we know by now that it is related to the expression languages used in the template engine, and they are being evaluated and parsed at the runtime. That's where the problem sits. Okay. From here on, I want to move into one of our previous labs. By the way, this issue also exists in C#, in Java, in JavaScript. You can feel free to pick any of them, and you can see the exact same problem happen there. But for now, I want to head to our TypeScript lab again. And so this one here, and start looking to write a security test for it. And by that, I want to look at to introduce with the tests that we have within each lab. So each lab comes with two sets of tests. One is called security test, the other one typical unit and usability test. The usability tests are kicked in when you build a lab. However, you can also run it separately to that. So let me head to the TypeScript server-side template injection, make build just to make sure, yeah, all done. If you run make test, this make test will run pretty quickly now because it's already been executed before. This just ran these sets of usability tests for us. This is again a helper function, a helper for us to quickly run all the usability tests. We also have another make command called security test. This will run the security test within the lab, where you can see here at the moment, I'm having only one security test here. that should escape the HTML when HTML is entered. It will make a call to this update endpoint is a post request, and it will pass in first name Alice following with the HTML tag, last name ID, and it will also the expectation is the assertion here is I want to get to 200 and I'm expecting to see the sanitized version of Alice, which is good. And we know that this template engine, Pog in this example, already cater for this case. So that's now test is running. And yeah, if you scroll down, anytime you see this message, this means happy days. However, we'll come back to it. You can see here this test has passed. All great. But as the comment says, this test is, well, this security test is incomplete because we're not really testing for the SSTI. So what we can do now, head to this test and clone this and copy this test, and we want to write a test for SSTI. So should this allow SSTI payload, a sample SSTI payload. And inside first name, let's just, if you remember, let's just pop in the example we had, not ampersand, 7 multiply 7. And so what I'm actually expecting to see that this program should just give me 400 when it sees the payload like that. And this is effectively, if that is not the case, this test will fail. So just make this modification, head back here and run make security test again. Perfect. Oh, well, this is where we see if we have a problem with any of your tests, we are going to get this error message out. And as we expect, the program could not handle SSTI payload properly, and instead of getting 400, we received 200, unfortunately. Okay. Now for next step, let's go back and patch our program. Right, so as we remember, everything is within this update method. Let me close this as well. And as you can imagine, the issue happens inside here where the double rendering happens. Now there is one thing I want to just call out right now. Perhaps we may quickly think that, okay, this is an issue to do with well, incorrect usage of that return value that comes from the mailer. And we may just head to the code quickly, perhaps remove this resource, maybe we replace it with some other, I don't know, your profile is updated, something like that, to thinking that, okay, we got rid of this problem. Well, that's this kind of patch, or this kind of quick patch, let's put it this way, it may work under the context of a simple program as this. But if you imagine in a large code bases that there are multiple functions and classes, controllers, multiple services are involved, it may not be easy to track down all the cases which could lead to double rendering. And most likely that was the case happened in the incident that we talked about. If you have a way to track down the issue, well, a quick fix will go to, you just go there and exactly getting rid of this problem. However, this is not a robust way for us to address this problem. The problem is actually somewhere else, which in our workshops, our defensive programming workshop, we talk about a number of principles to how you need to go and properly address this issue, that you don't even have this problem from ground up. Now, we don't have all time available for me to go through the details of every principle now, but I will quickly give you a snapshot of two of the principles that it's pretty effective in addressing this security bug and a number of others. So the first thing we need to look at is when it comes to the situation behavior is like this, is that where the data enters our program, or what is the first place that this data is being processed and parsed, and if there is anything we can do. Now, before you start thinking about input validation, input sanitization, which I think the web is filled with that, the approach of this defensive programming principle is slightly different. It talks about, rather than we building a big barrier around our program to keep all the bad data out, we take a different approach where we make the core of our program more robust, so the unexpected data, in this case a malicious payload, would not be even representable by our program. So the key thing here is that we make the core of our program so designed in such a way that untrusted data would not be able to even get represented. So that means that if you look at the line 7 in this code, when this parser did its job and parsed the post parameter, it will pass in the parsed data to this variable called payload. And what is the type of payload? Even if you don't know the TypeScript, that's clear. It is that any means whatever, and whatever means whatever even the adversary puts in. And that is where the actual problem starts. So right at the beginning of our program, we have in this case, a data model or a variable that represents something that we do not even expect to have. Hence, we may need to perform validation on that to make sure that that value is within our expected values. And that's a common, I would say, common problem with most of the input validation approach. Here comes in that when right at the beginning we are receiving, or in this case we are representing something that is not expected, we need to track down where this variable, in this case payload, is used across our controller or views or storages, and making sure in every place there is enough sufficient validation is done so we don't get security issues, in this case SSTI. And again, if we follow this approach, well, this wrong approach that we track down where a bad data is being used, most likely, more often, we're gonna miss some of the validation, because you should imagine this is just a single endpoint. We may have multiple endpoints here. In every single endpoint, I need to make sure whatever comes in has went through enough validation before usage. So it's more like a coding convention that we have in our code, that as long as the same developer with the same sets of experience following it, we are safe. However, if the code gets refactored, if there is a new person join a team and does not follow that convention, we may be able to, we are exposed to security bugs. So is there any way for us to address this problem? And this is where one of these defensive programming principles is super effective, is because rather than we rely on a coding convention or this validation logic scattered across our code base to make sure the data is safe, we take those validation logic in one place, and that is the core of our program. And what is in core of the most programs you will find is your data model, is your custom data types, is the things that your programs will operate on. So in other sense, here, rather than I assign, so this could be specific to this framework that I'm using, but it's a similar approach. You can apply it in other languages as well. Rather than I use a type called any, I will define something as like safe user. So this is my own type. But then I need to go and start defining this. So this is where I'm going to take in all those validation logic, all the things that need to export class, all those in one place. And the nice thing about that is that anytime I want to use this payload, I already know that it has been already validated and sanitized. So what my safe user is doing, well, I need to have the attribute that I'm expecting to receive from the user. So I need to have ID, last name, and a first name. So let's just quickly define those. So I have an ID. At the moment, I'm calling it a string. The better data type for ID would be, well, int or number. I have a first name. And I'm going to have last name. Cool. So far, I haven't done anything. Still, I haven't performed any validation, nothing. One of the nice things that this framework can give to us is a number of annotator that we can, or decorator that I can use to enforce some validation on, well, on the parameters that I have here. Even if we don't have that access, it's completely fine. You can just write a logic for those validation that I will go through. So in the case of, if you're using this TypeScript framework, tset, you can use this annotator that I will import soon. So what I want to do here is that once the body parser passed in the parsed post data to the payload, it tries to map whatever it sees in the post request to whatever I have within safe user. So ID to ID, first name to first name, last name to last name. But before this assignment happens, I want them to go through a validation. I want them to go through a number of security checks, safety checks that I do not even assign a value to first name, which in the first place, I do not even expect to even have it. So again, you may hear a lot about input validation, or we have to do input validation on our data, make sure untrusted data doesn't come to our program. The question that you may have is, what are the data properties or things that you need to check to make sure that, well, your data is fully validated or is safe to use? There might not be a clear guide on what those checks are, but we can narrow this down to a number of safety checks, which is the subject of our different defensive programming principle, that there are minimum 4 checks you need to do on any untrusted data at minimum. In some of security vulnerabilities, more than 4, to just make sure that this data is safe to use in your code. Now, one of the most important checks that a lot of times you may see it's being missed is void safety, or simply does the data exist? Is the data null? Is the data a NaN? Simple as that. In this case, I want to make sure that whatever I'm getting from user, it does contain all the parameters that I expect. The next safety check that we must apply, again, regardless of what data you're dealing with, is range safety, minimum and maximum. And our fourth check is format safety. This is more tricky than all the others to apply. This is where we need to make sure the data is normalized and has a right encoding, or let's put it char set. And finally, syntax safety, which effectively, most of the time, you want to think about irregular expression here. I think at most, when I look at a code base which has followed some security practices, I may find just this line, a safety check, which, well, again, is not in context of this workshop, which we will find is actually not a really good check to have without having these prior checks, safety checks. Okay, so from here on, I just want to look at these parameters that I have and apply these safety checks on them. Now, for void safety, in this framework, I can use an annotator called required. I actually want to add that to all the parameters that I have, because in the context of my, in the context of my program, it doesn't make any sense to have a null parameter here. I mean, my program should not even deal with a situation where there is no data for that parameter. Now, the second check I want to introduce here is for, let's say, first name, well, is our range safety checks. So I want to say, at minimum, I want to have one character. I mean, I don't want to accept anyone who doesn't have a first name. And for my maximum length, well, let's limit it to, I don't know, 128 characters. I don't expect to have someone with bigger range than that. And finally, I'm going to skip the format safety checks for the simplicity. I'm going to move into my syntax check, where I can use an annotator called pattern, not canvas pattern, just pattern. And okay, and here I can enter the unexpected regex that I believe makes sense given the context of the field that I'm checking. So in this case, I'm looking at maybe I will limit it to just A to Z. It's really restrictive. I'm sure we can come up with better examples here. So this is effectively telling me that it only ASCII characters, sorry, the A to Z capital and lowercase are allowed in the first name. I mean, we can use things like that, for example, to limit it to a visible ASCII characters as well, by just giving it a, like, I think it's like 20 till x 7e, something like that. So it's more a lot, but again. And yeah, I want to have the same requirement also here. So if I just copy this here and then right here, and then right on the top, I need to import these annotators. So we have required, we have min length, we have max length, and we have pattern. From this, I think it's common or schema. Yeah, schema. There we go. So I can get rid of this. I haven't applied anything for ID at the moment, just for sake of time. So just for first name, that's where perhaps my most interest is, and then perhaps a little bit on last name. So that means that now, once parsing happens, once the mapping is done to my safe user, well, data model, the first name parameter will enforce those safety checks that I want. All right, so let's compile this. Make build. If we have done everything right, these tests should pass now. Perfect. So this is now our usability test. We can see things are passing. Let me try again. I think I haven't saved this file. Let me save it again. Run this again. Okay, let's run this again. Okay, so it seems like I have a problem here. So yeah, I think I need to look into where I have something wrongly defined. So export class safe user. I got required ID, required. Maybe for the time being, I get rid of the checks on the last name. And the payload here, just to double check. Yeah, safe user, and change anything right here. And let me check my regex again. A to Z plus string first name. Let's maybe try this again. Required min less, max length, and pattern. Okay, to figure out what is this error, no, this is a good debugging exercise for us as well. Since the test is run as part of the build, we can't really run the program to find out what the issue is. What you can do, you can go to the Docker file for this lab and comment out this line where it tries to run the test. So we skip that line, so at least we can build the program and then see what is wrong with it. Okay, so and now I head to make run. Let's see if I get any issue here. Alright, so it seems like it's been running fine. Let's head to the browser and open up 8080 fresh. All right, let's just put in some value and see if there's anything wrong there. Profile is updated, so it does get it. Okay, of course. This change that I did right at the end is causing the issue. There we go. Okay, so the issue is effectively on this line when I was talking. I changed this to some other string like that. So, well, lesson learned. That should be res. So hopefully this time, just kill this. Let's go back to the Docker file, bring back that line, come back here, make build. This time, hopefully the test will pass. Hooray! Both tests are passing for usability test. But how about our security test? Because now our security test contains this rule right here. And I think what's going to happen is I also need to modify this test because it's not going to return 200 when it receives well, let's run it first. We will see what's going to happen. It's going to return 400 if when it sees something is not according to the spec that you have defined for your parameters. So I imagine our second test will pass, but our first test will fail just because of this assertion. Yeah, as I expect, one failed, one passed. So which one failed? The cross-site scripting one failed because it received 400, but there we go. Our SSTI one is passed. Let's just fix this test as well. So we are expecting in the current stage of the program, if user enter anything that does not follow this specification right here, and that's the beauty part of it, right here, right at this line, we're gonna get a 400 back. That, hey, you can't do that. And let's run our security test again. Hooray! Well, you have now passed both tests, so let's just see in practice. Make run. And let's head to our browser. Head back here, refresh. All right, let's try one of the payloads from the before. Let's try the cross-site scripting one. Script, whatever here. Well, not whatever, we need to be careful what I'm putting here. That's why we're getting 400. So yeah, it's not really easy to read here, but we can see here bad request on parameter request body. The safe user first name must match pattern as we define. Perfect. How about our SSTI payload? 7 star 7. Let's try that. There we go. Again, another 400 come back because we could not get it through. Perfect. So I think now by now we've got our program patched. We make sure that those safety checks. Let me go back to again review what we have done. First of all, we have updated the security tests. Our security tests now contain a sample SSTI payload, which tests that the program should disallow. We have also updated our cross-site scripting test just to align it with the current stage of the program that we only received to expect to get 400. Moving back to our patched version of program, the only change we did is on this line effectively that I'm not even allowing anything comes to the program, or better to say that I'm not representing something that the program should not even process right at this line when there is assignment happening from the post body to that class data model that I have, which contains my ID, my last name, and my first name. I'm taking it through void safety, so it must exist. Minimum length safety, that's our range safety, and maximum length, and our regular expression. Just to mention here, I don't have my format safety here, which is a bit more, it needs more a bit of code to introduce it here. The other nice thing about this design pattern or defensive programming principle that we have here is that now within your code, you have a data model that when it exists, it is valid, it is safe, and you can use it. So feel free to pass this around to any other controller you may have, any other endpoint that you have, or even pass it along to different services, because we know if this exists, it is valid. If it doesn't exist, well, it's invalid. In our case, it's unsafe, so you should not even operating on. Obviously, there are more things we should be doing here. We should go back and also make sure that, well, we don't necessarily return back an already rendered template and then re-rendering it again. This is more like defense in depth type thing we can do here. But for the sake of our lab so far, whatever we have done, it's sufficient. All right, I think I went way over the time that I allocated for this workshop. I may not have time to go through the exploitation phase to actually show you that, well, I just only show the arithmetic that you can do using SSTI, but what about a full remote code execution? Perhaps in one of the future workshops, I will pick one of these labs and go through the detail of one exploitation technique, well, known as a code reuse plus metaprogramming, that can be used to turn this seemingly only arithmetic operation into a full code execution on a server. Now, if you are curious to learn more about these exploitation techniques or other labs, I suggest you have a look at the Python one. In some of the labs, it's a lot easier to create the full remote code execution. Python one is, I think, the most fun to do. If you head down right toward the end of this guide, there is a bonus section that we are talking about introducing that technique and the things that you can do to eventually, well, run your desired command. Well, let me just quickly check the live chat just to see if there was one question. Yep, thanks Jacob for the comment on makefile. Yes, makefile are just helper for us to just rerun the same command again and again. You can look at inside a makefile to just find out what commands are actually being executed. So if I just, for example, open this file, for example, the run, it just runs this Docker command. You just copy this out. But I would suggest to have a make on your system. It's a lot easier to use than running a bash script. And the other thing is around, Jordan, why there aren't warning or protection surrounding libraries that result into SSTI? I don't really know. A lot of times we always have this assumption that our engineers are well aware of all the possible edge cases, but more than often that is not the case. I think sometimes we are introducing some of these libraries for a different problem or different functionalities. We don't necessarily think about the side effect. And if you think about it, the security bugs typically deal with the edge cases, that repurposing something that was designed for something else in this case. Now, and this is an example of the SSTI, and it's unfortunately quite widespread, and we just need to be quite tactful in the way that we are using them, especially when it comes to double evaluation bugs. Is one of those that is even hard to track down. Now, lastly, what I want to mention is anytime you want to test for SSTI, is a lot easier to test it at the runtime, especially in a large code bases. But the trick is you should have the full environment set up. If it's multiple, I don't know, pods and containers are involved, all need to be set up. And you need to see the output from each of those just to make sure that what you have entered has not been double rendered across the line, because it may be safe in one of the services, but when the multiple services are involved, it may not be. And a lot of log aggregation systems or those centralized log systems could be also open to this if they are trying to render what is being logged back to perhaps the operator of that system. So yeah, I hope you enjoyed this workshop. Let's the conversation to continue on. Head to discuss.secting.com, which you can still ask your questions. And with that, I want to conclude this and hopefully see you guys at our next month's workshop. Thank you.